Hello and welcome to this first lecture on our basic and advanced physics course. So, first of all, in this lecture, we will be studying about what is physics and some major branches of physics. Starting now, what do you think is physics? What is physics? It is basically, we can call it a science of nature. So, physics is science of nature. Moving forward, going to the definition. Physics is the natural science. Basically, it's a natural science, and it deals with the study of matter, energy, and their mutual relationship. Or we can say, deals with the study of matter, energy, and the fundamental forces of nature. So, physics seeks to understand how the universe behaves, from the smallest particles to the largest galaxies. So, this is defining its scope, right? So, it is one of the most fundamental scientific disciplines with the goal of understanding how the universe behaves at every scale, right? The word physics is basically derived from a Greek word. It means nature, nature or origin. The discipline or this discipline, it was basically for centuries, it was intertwined with philosophy, and it was known as natural philosophy before emerging as a distinct scientific field in the 15th, 16th century. So now, uh, what basically physics study about, right? Physics basically studies about, it investigates the following fundamental questions like what is matter made of, and how do the objects move, and why do the objects move, and what are the fundamental forces of nature, right? What are the fundamental forces that govern this nature, and how is energy stored, transferred, and how it is transformed from one form to another. Similarly, we study in physics about the structure of space and time, and we study how did the universe begin and how will it end. So physics does not answer why in a, in a philosophical sense, right? It answers how through precise mathematical laws. And for example, physics tell us how gravity works, but it does not explain why gravity exists in the first place. And okay, finally, physics uses mathematics as its primary language. So without mathematics, physics would merely be qualitative description rather than precise science. Some of the most important mathematical tools in physics include algebra, calculus, vectors, differential equations, stats, and probability. Okay, so now the scope and goals of physics. So, what the goals of physics are? Number one, to discover the laws of nature and to formulate the universal laws that basically govern all the physical systems, right? Number two, to understand the fundamental forces like the forces of gravity, electromagnetism, strong and weak nuclear forces. Number three, to predict and to explain the mathematical predictions about natural events, to forecast or to predict the behavior of things, to predict the nature of sciences. And number four, to unify the knowledge, to find the connections between seemingly unrelated phenomena, right? So that's basically some major goals of physics. And now we will be looking at the scales of study, right? What does physics encircle? So it starts from, right, the quantum scale, from subatomic scale, smaller than 10 raised to the power minus 15 meters. It studies quarks, electrons, protons, and the forces between them. Secondly, at atomic and molecular state, Here we have atomic and molecular state. So the size of 10 raised to the power minus 10 meters. It studies atoms, the chemical bonds and molecular structures governed by quantum mechanics and electromagnetism. Then at human scale, from 10 raised to the power minus 3 to 10 raised to the power 3 meters, it's classical mechanics, thermodynamics, optics, and electromagnetism apply here, right? And then at astronomical scale, we study about the extremely big objects, celestial mechanics, gravity, the topic of general relativity. They become important at this scale. And cosmological scale is another scale that is the largest scale of the universe. And we cosmology and general relativity govern this regime. Okay. So moving forward, we will study now about the difference between classical physics and modern physics. So first of all, we'll be starting from classical physics. Okay. So classical physics basically refers to the knowledge that was developed before 1900. That was developed basically before the revolutionary discoveries of the early 20th century. So this classical physics and this knowledge remains highly accurate for describing everyday phenomena at the human scales and at normal low speeds, right? So some of the few major branches in classical physics are mechanics, thermodynamics, optics, electromagnetism, the mechanics. We'll be studying about all these topics, all these concepts and laws later in this course at advanced level, right? So now the next thing is modern physics. So after 1900, the knowledge that came, it was basically the era of modern physics, or we can say that there were two revolutionary theories that emerged around the turn of 20th century, and those theories that completely transformed our understanding of the nature. So those theories were basically quantum mechanics that started from 1900 and onwards, and then theory of relativity around 1910 1915. So in modern physics, we'll be studying these topics, especially quantum mechanics, special and general relativity, nuclear physics, particle physics, solid state, condensed matter, cosmology, and astrophysics. So these are the topics that are included in modern physics.